Today, at this winter day, we're starting our new webinar, online demo for cable and pipe locators, manufactured, developed and manufactured by TECHNO-AC. And today we're testing our new microphone, so I would like to ask you if you can see and hear me well. Just send plus in chat box if you can see me and hear me. And we will move on to the core part of our event today. So while you are typing pluses in the chat, I will introduce myself. My name is Dmitry. Most of you received emails from me with information about TECHNO-AC equipment. I'm technical engineer, and I'm doing technical training, technical consulting, and technical presentation of TECHNO-AC equipment. Generally, I participate in the whole process of TECHNO-AC equipment creation, starting from the development, uh, moving to manufacturing, and also I'm dealing with the supplies of this equipment. So if you have any questions regarding TECHNO-AC equipment, you can contact me through WhatsApp or through email indicated on our website www.technoac.com. My operator says that the sound is fine. So I guess we will be moving to our today's topic. And today we're going to talk about the cable and pipe location equipment. And generally, we do our events during these winter days in the building, inside the building. Some of you who visited our cable fault location event 2 weeks ago may remember that we did it inside our building. But today I decided to go outside to show you some Russian real winter and to demonstrate the equipment in real working conditions during winter period. I know that winter is not a problem for most of you and that you are having more warmer climate. That is why we will be just checking the application of the equipment in real conditions, but just take into consideration that winter application is also possible. So, what do we have today? Today we're having one of our most popular utility location sets, which is called AG309.15N. That's kind of complicated name, but this is one of our most demanded instruments so far because it has some most demanded features in the market. And I guess I should give you the description of the set contents, what's supplied within this set of equipment. And I will start with the main thing of this set, the core. It's the receiver. I'm using AP19 receiver. It can be of any model. I mean, we have several models of them. We have GPS receivers, we have non-GPS receivers, so there are multiple options. Today I'm going to use the GPS receiver, but we will not be taking any GPS coordinates. I'm using it just for the demonstration. Also, second important thing in this set is AG105 transmitter. This is it. It's a portable 20-watt transmitter featuring direct connection, inductive connection, clamp connection, and also it features several modes like two frequency modes, like pulse and continuous mode of operation, and it can be powered from 8 Type C batteries or Type C accumulators. Okay. Uh, Meanwhile, uh, no, sorry. Most of you know that our devices are called cable and pipe locators. And for pipe location, we have a magnet contact which is supplied within the set. It is used for applying the magnet to a pipe and connecting crocodile clamps to it in order to connect the transmitter directly to the pipe. We're not going to use it today because we don't have exposed pipes somewhere here in the area. But we will be locating first. We will be locating 50 hertz cable, power cable, which is laying behind our building. And after that, we will be locating the that cable on our test field with a transmitter. We will be creating the frequency uh, inside the cable. So now I would like to explain you a little bit how does cable locator work. First of all, we should know that almost everything or almost every metal object can pass through itself an electromagnetic signal, and it means that this signal can be passed through or emitted outside the object, and this signal can be detected. Generally, we start with a demonstration of 50 hertz power cable, and the physics behind that is the following: the current, electric current, is floating through the cable from the substation to the building, for example. And while it's floating, while the current is there, it creates an electromagnetic signal, electromagnetic field actually. And the receivers, these devices, they detect the level of this signal. So if you are locating the spot with maximum electromagnetic signal level, you locate the cable or the pipe itself. Now let us see how in real conditions the location will look like. Let's go behind our building. You can see that there, there is there is a lot of snow. There's the big snow mountain for like 2 weeks of snow. You can see it's almost twice higher than me. Yeah. Okay. Uh, so what are we doing first thing? We turn on the receiver, wait for initial animation and status info to go away, and then we make sure that the device is working on 50 hertz frequency. Actually, it already detected something, so we only have to check. But we have to be sure that it's working on 50 hertz frequency. This is the power frequency of most cables in the world. Some countries, like the USA, they have 60 hertz frequency of power electricity. This device also supports this feature. You can switch to 60 hertz frequency and use it for power cable location. Okay, so now we're standing a little bit right from the cable. You can see that the black line representing the cable is a little bit left of us, and then now I will be moving towards this line, and let's see what's happening while we're doing that. I'm making only 2 steps, easy as that. And now we can see that there is a cable, and when we have a cable inside the central part of the display, we can see the depth and the current which is currently floating through this cable. We can see that the depth is approximately 1.3 meters, 1.4, and the current is 14 to 15 amperes. So how do we trace the cable afterwards? We just following the image of the cable on the screen and make sure that cable is staying in the center of the screen as long as possible. So we will do it the following way. We're going and checking the cable all the way when the signal is there. From time to time, each, I guess, 2 to 3 meters, we stop and check. We give the device some time just to check if we're still on our cable, like this. Yeah, we're still there. It's still there, and we can move forward. I already know where is this cable going, but the device is also giving me the direction because I can understand that if the line is going that way, I should follow it. And while I'm moving alongside the cable, the device adjusts my position so I can see where the cable is going. I can follow the signal. I'm tracing it. I'm stopping in I guess, yeah. We can see that the cable depth increased because it is going to the building basement. That is why it's the depth is increasing, and we can trace it the whole way up to the building. So by observing the position of the cable, we can tell that it is going somewhere to the building, somewhere there, like this. Yeah, we can see that the depth is maximum here. It means that the cable is going to the basement of the building and it supplies the building with electricity. Yes. So, what information did we get from this experiment? We have located the live cable with the receiver only. The cable is working on 50 hertz frequency. It means that it's power cable and it's live. And we trace it the whole way from the fence of our yard to the building. Uh, and we know that there is a substation there, so we can trace the whole way from the substation till the building, and we can tell where the cable is going. Also, we have measured the depth of the cable and checked the current level of which is floating through the cable at this particular moment. I would like to add that uh, current rate, which is measured by the receiver, it's not the exact value. It's evaluation of the signal level. So you have to be careful because if you measure the current with multimeter, the measurement of course will be different because device receiver evaluates current rate from the ground surface. You see, that is why that is why uh, you shouldn't rely on these measurements 100%. This is an approximate value, so be sure that you understand that and check everything with more accurate and with direct connection instrument. Regarding the depth, of course, each device has a fault rate, and our device is no exception. And Success AG 309.15M has its fault rate approximately plus minus 3 to 5% of depth and of depth. Yeah. So it means that if you are locating a 10 meter cable, which is laying 10 meters below uh, ground surface, the fault will be approximately 3 to 5 centimeters. That's quite accurate, I guess. But it depends. It depends. Okay, so we checked the power cable now. And now we will be checking the dead cable, which is just laying below ground surface, and it doesn't carry any current. And we will have to create this electric current inside the cable. And we will be using a transmitter, AG105 transmitter. We will create the signal inside the cable, and we will create it on a particular frequency which is recognized only by the receiver. So we will be using them in pair together. This method is used uh, for how can I say, exclusion of unwanted electromagnetic signal. If the transmitter created 50 hertz signal, it the signal would mix to any other electric signal, but the transmitter creates uh, a special frequency signal which is recognized only by the receiver. It helps us to be sure that we are following our cable. Okay, I made some preparations and I just want you to see what did we do for the connection of the transmitter to a cable. First thing we did, we used the hammer and the grounding rod. We just put the grounding rod inside the ground surface as deep as possible. Uh, as you can see, it's snow everywhere, and it means that the ground is frozen, and you have to put some strength in order to stick the grounding rod inside the ground surface. I'm using the hammer, and it's very helpful. Also, it's not, by the way, it's not supplied with the set. It's just an optional accessory for winter location option. Okay. Also, I used the connection cable with Crocodile clamps. This cable is supplied with the set, and it has two clamps, red and black. The black one is on the other side. I will show you in a minute. We just connect the Crocodile clamp to the grounding rod, and we go all the way to the connector, which is in the middle of the cable. We will clean it off the snow, and we will connect it to a transmitter here, like this. You can hear, I guess you could hear a click of the port. Now we're ready to go. I will turn on the transmitter. I will select 1 kilohertz frequency because 512 hertz works bad during winter. We will use 1 kilohertz frequency. I'm starting the transmission, and the device is gaining its power. I guess it will give us full power because I didn't smash the grounding rod inside the ground too deep. Yeah, 40 volts, full power. Okay, now we will be moving on the other side where we have connected our cable. But first, I would like you to see that we're changing the frequency of the device. We're using the menu button, frequency, and we're selecting 1 kilohertz frequency. You see that when I'm doing this, the signal is absent on the screen, but it shows us something that way. It's something there, and we will see what's in there. Okay, so there's a lot of snow here. You can see it that deep. So we will be moving step by step just to follow the cable line. Okay, let's move to the cable joint box, and I will show you what we have done with the connection. This is our junction box where we have all the cores of the power cable split inside this box, and each of them has its connector. And you can see the black crocodile clamp connected to the end core of the cable. Now the transmitter, which is standing there on the table, is transmitting the signal inside the cable where we have connected our black crocodile clamp. And the cable is going all the way down below ground surface, and it goes from the place where I'm standing till the end of that fence. And now, while the signal is there, we will go a few steps away from the junction box. I guess it's 2 to 3 meters. And we will try to see where is the cable. Let's go here. The procedure will be the same. We're just turning on the receiver and observing the cable line on the screen. Again, if we would locate a pipe, the situation would be the same, but we just use the magnetic contact in order to connect directly to the pipe. The procedure will be the same. Okay, we just place the cable in the center of the screen. By the way, I'm not sure that you can see, but the screen is backlit. It means that you can work. If it's too dark outside, you can still locate the cables and use this equipment even at night. And now I'm sticking the device in the snow just to check the depth. I guess now it will not stand by itself. Yeah, we will do it like this. And you can see that the depth is 60 something, 65, 64 centimeters. And the current is very low because the ground is frozen. But it's still there, the signal is still there. And we can go all the way there in order to check if the cable is still there. I'm not sure that I want to go there because there's a lot of snow, but instead of this, I will show you one extra feature of this transmitter. We never did this before. I mean, in online demonstration, we will do this now, I guess, and I will show you how does this thing work. Let's go back to the table. I will put the receiver away, stop the transmission from the cable, and now we will be using the inductive antenna, which is built in inside this transmitter, in order to create the signal without direct connection to the cable which we are looking for. This feature can be used when you need to excavate some area and you don't know if there is any cable and or pipe, and you don't have access to the underground utilities or to the maps. You just put the transmitter on the ground and scan the area around it, but make sure that this arrow um, complies to the orientation of the supposed pipe or cable. So when you are going to locate the utilities in the area, you will have to rotate the transmitter from time to time in order to create the signal everywhere around it. So what are we going to do? We just put the transmitter in the snow and start the transmission. We will do this like this. I will press start. The transmitter is gaining its power. I'm closing the lid. Make sure that it's completely closed. The transmitter is IP65 protected, but only when this lid is closed. So we will do it the following way. We'll just put it on the snow like this. Let's keep him here. I'm switching the receiver to one of the supported frequencies for induction. And induction frequencies are the following: 8.2 kilohertz and 33 kilohertz. What do we see here? Let us check. See, while the transmitter is still there, we can see the cable. The signal is very poor, but it's still there and it is induced on the cable. We can't measure depth, I guess. Yeah, let's make it. Yeah, you see, we are detecting the same cable now, but due to the signal emission, we're seeing much more depth, so it's not that accurate. But we can see that we're standing above some metal object, which presumably can be a cable or a pipe. That's what this mode is used for. But we can see that the current is pretty high, more than an ampere sometimes. It's because the signal from the transmitter is going everywhere. It's going like an antenna. It's emitted everywhere, on every metal object, even on this fence, or I don't know, any metal object around. So you have to be careful with this mode. But again, this mode is useful when you need to scan the area in order to find any metal utility in the given area. So you place the transmitter onto the ground, you rotate it and scan with the receiver and see what's in there. And it will be indicating any metal object which is capable of passing of electromagnetic signal through itself. Okay, I guess that we can remove our transmitter from the snow. I will remove, take away the snow from the device, and I will turn off the transmitter. Okay, just like that. Yes, and now we can move to the question and answer session. I will turn on my phone just to see your chat messages. Just give me a second, please. I'll be using my phone and click meeting app. Hold on a second, please. Yep. So now you can see joining me the event, and you can ask me any questions. I will read the chat back and I will reply to all of your questions. So the question from Mr. Samnat Kundu: max current it can measure. For this particular set, the restriction, the limitation is pretty simple. It can detect and measure the depth of cable up to 10 meters and also measure the current up to 10 amperes. That's easy as that. Does the transmitter also applicable to find the fiber optic? The question from Alexander Ray. Yes, it is applicable to find the optic fiber, but you have to know that this device is most used for the location of armored optic fiber. So if there is a if there is an metal armor coating of the cable, you have to connect the transmitter directly to it, and then you will be able to trace the cable. If the optic fiber is unarmored, it doesn't have a metal armor in there. So no, unfortunately, this device won't help you at all. How to select two frequencies? That's kind of a good question. We also never showed you. Let me just clear all the snow. This wasn't so pleasant, I guess, but that's just the conditions we're working in. Okay. let me show you how. So first, you are turning on the receiver. Then you will be able to press the mode button and select the induction method of the transmitter. And by arrow keys, you can use continuous when the signal is going all the way, pulse when signal is coming through the cable or pipe in pulses, and to frequency. And you just press start button, and device, the transmitter is giving 1 kilohertz and 8 kilohertz inside the cable or pipe simultaneously. This mode is used for the orientation, for the location of the cable direction. So you can locate the cable direction by checking the cable on each of the frequencies. That is how you can be sure that you are walking the right way of the cable and you are tracing the right cable. It's easy as that. So I will repeat just for you to know. You turn on the transmitter, press mode button once, and with arrow keys you select 2F mode, and then you can use it by pressing start button. Easy as that. Yeah, it's easy as that. And for the receiver, actually there is a dedicated mode in the receiver for this particular frequency selection. You will have to use, just hold on a second, I'm trying to, yeah, it has. First, you have to enable extended set of operating modes, and then you will have to use, where is it? To frequency mode. Yeah, it's called the same, and that is how you will be able to evaluate signal level. This is going to be signal direction when you will have the signal inside your cable, and this is the correction information. You can read more about it in the user manual. It is used also for the evaluation of signal level. So this device also supports multiple frequency. You can see that in this particular mode you can use both 1 kilohertz and 8 kilohertz, and there are no any other options, unfortunately, for now. But later, in later devices, we're going to use more frequencies for this two frequency mode. I hope that that explanation was clear. How to detect pipe with a new magnet? Samnat Kundu asks us again. It's easy. How? I will take a crocodile clamp from this side just to show you. Suppose our table is a pipe. We apply the magnet to a pipe. Then we apply a crocodile clamp to it like that. And that is how transmitter will create a signal in the cable, in the magnet, and in the pipe afterwards. And the process will be the same as with the cable. You turn on the receiver on the same frequency and you trace the pipe all the way. Easy as that. What is the maximum distance transmitter can send signal? Amer Fuad. For this particular device, maximum distance is 3 kilometers. We also have more powerful transmitters which allow you to extend the distance up to 10 kilometers. But we made some experiments actually with optic fiber and armored optic fiber, and we've managed to trace the cable up to 33 kilometers. You can read about this on our website in news section. And actually, these values, 3 kilometers, 10 kilometers, are given just for average tracing conditions. If the conditions are better than average, you will be able to walk to trace the cable or pipe even more. If the conditions are worse than average, then the tracing distance will reduce. That is why we're indicating the average value. How the receiver can find the end of the cable. Uh, Generally, you go all the way the cable line, and in some point you reach the spot of a manhole or another junction box or a substation. So the receiver itself doesn't locate the end of the cable. It locates the position of the cable and direction of the cable. Also, it is capable of depth measurement and current evaluation. But generally, you, the person who is using the locator, you reach the spot where the cable is ending. I mean, the substation, the junction box, the manhole, it's there. You may be sure. If the signal is not going any other side, any other way from this particular point, you may be sure that cable has ended there. Okay, any more questions? I will be glad to reply. Just hold on a second. If there are multiple cables together, yeah, it happens sometimes, but generally we recommend to use direct connection, and the lowest possible frequency for this particular transmitter, it is going to be 512 hertz, and this is the main precaution of locating multiple cables in one spot. So you connect the transmitter to one of the cables and create a signal on 512 hertz frequency, and you check it with the receiver. 512 frequency is a low frequency. It means that it can't be induced on other object laying nearby. 1 kilohertz frequency, which is the next step for this transmitter, also is a good one. It doesn't go to other cable or pipe laying nearby. But starting from 8 kilohertz frequency, this signal can be emitted literally everywhere, on every metal object. Cars, fences, light posts, anything. That is why, if you're having multiple cables, you connect the transmitter to one of these cables and create the lowest possible frequency signal. That is how you can exclude the influence of other cables laying nearby. The frequency is the key to successful location. AG105. When the battery indicates 11 volt, the unit switches off itself. Is it normal? Generally, yes, it is normal because the working voltage for this device is 12 to 11 something. But if your device is behaving like that in a short period of time, you have to contact me or contact TECHNO-AC through the website, and we will inspect your situation more thoroughly, and we will see is it wrong or right. Because I can't give you the information just at once. Just send us an email and some maybe videos or photos of the device, and we will check. Okay, if we connected transmitter in middle of the cable or pipe so it is send the signal to both direction, is it affected to the signal? Uh, if you connect the transmitter in the middle of the cable, first you already know where is the cable. Why do you need a locator then? The second, if you create the signal both ways, you can trace the signal both ways to the end points. I mean the substation or the manhole or where it is going. And the third, it will not affect any signal because you are creating this signal, so it is going both ways. It's like the electricity wire; it's going everywhere alongside the wire, so it can go both ways, and it will be fine. I guess there may be some, how can I say, reduction of tracing distance, but if you're connecting in the middle, or yeah, in the middle of the cable, it should be fine. You should be able to trace it up to the next key point where you can reconnect the transmitter and continue tracing. Thank you, Nilesh. Your Russian is very good. Thank you. By indirect mode, can you find the live electric power cable too? Uh, this is a question by Do-hyun Kim. You don't need to, because the receiver can detect power cables by itself. We will after this particular event, I will send you the email which will contain the the previous videos of our webinars, and there is one video which is called Area Survey Before Excavation, which describes the process of area scanning in details. And the main one of the main steps in this method is, first you locate you scan the area with with receiver only on 50 hertz in order to see if there is a power cable. You don't need the transmitter for that, and only after that you place the transmitter on the ground and you check the area with the transmitter. First, you just check it with receiver only on 50 hertz or whatever frequency in your country is, and after that you turn on the transmitter. When do we use two frequencies? Two frequency mode is used when you need to know the direction of the cable. See, sometimes you have to check if there is a damage on the cable and the current is floating to some other cable, or you have to know where particular the current is going, or you're locating a cable in a bunch of cables which are laying nearby, and that is how you use the frequency mode. First, you indicate the direction of the cable of the current which is floating through your cable, and you see actually an arrow on the screen, and this arrow indicates where the actual electric current floating alongside the cable. And if you are tracing the cable and suddenly you see that the uh, arrow is pointing backwards, it means that you are tracing wrong cable, which has been connected to the cable you have connected before. It's complicated to explain. It's very, very, how can I say, uh, rarely used mode for particular particular moments. But generally, you may know that you can tell that this mode is used for the signal direction. It is this mode is for signal direction indication, for location of the cable in a bunch in multiple cables. That's almost it. That is when you use the two frequencies mode. Okay, any other questions? Thank you, Nilesh. Your Russian is improving. Each message is better than the previous. I hope my Hindi will be as good someday. Thank you, thank you. Okay, if you have any more questions, you can contact me. Uh, yeah, there is another question, and I will make a quick remark, and then I will reply to the question. If you have any technical question, you can contact me through WhatsApp, or through email, or through, I don't know, through the phone. Everything is indicated on our website, www.technoac.com. We are always replying to all the inquiries which were having from the website, from WhatsApp, from everywhere. So be sure you visit our website. Okay, you said that we can locate fiber optic cable without this device, but with Zondes we can fiber optic without armor. Yes, that's a good remark. Uh, we have a GPS version of the receiver, and it supports the pipe zonde operation. I hope that one day we will have another demonstration of this device. And yes, you can place a pipe zonde inside the duct where the fiber optic cable is passing, and you can trace. But in this case, you have to be sure that you are tracing the duct, not the cable, and you are measuring the depth of the zonde, not of the cable, but they will be approximately similar. Yes, it is possible. It is possible, uh, but unfortunately or luckily, I don't know. For now, our zone now pipe transmitters, uh, they are using a cable barrel, and the cable barrel is limited with 120 meters. So this is not the best result, I guess, in the market, but still, this is a solution. Yeah, you're right. This is a solution for non-armored optic fiber location. For locating ductile pipe, which frequency to select? If you mean the location of pipe transmitter, it uses one frequency, 512 hertz. This is a common frequency for all pipe zondes, pipe transmitters. Sorry, and we also use this frequency, 512 hertz. Okay. Any more questions? Okay, I would like to thank you for today's event. Uh, it was pleasure working for you during this winter day. I hope you enjoyed a little bit our Russian winter. Snow is everywhere and it's very beautiful. I hope that our equipment will be helpful to you and to your business and to your clients. In case you have any questions, you can contact me or our team anytime. And I hope you will join our next event, which will happen in 2 weeks. And I guess it will be dedicated to some other model of cable location equipment. Unfortunately, we can't do water leak detection demo because the pipe, which we're usually using for that purpose, is frozen because it's winter. And meanwhile, until March, I guess, the end of March, we will be having only cable and pipe location demonstrations. That is why I am asking you to join our events just to find out more about cable and pipe location. And also, I have a little announcement that you can book a private training and demo for any device which we're having in our range. Uh, in case you own already a TECHNO-AC device or you are going to own one of our devices, we can make a private demo and training. We can explain everything, and for those who are going to start the business with TECHNO-AC equipment, we have a special discount for a demo set after this training, of course. And if you're interested in such conditions, just let me know, and we will check. We will see what we can do about it. So I thank you all for your attention. Thank you all for your question. I really like this format of webinars because we can have real questions about real working conditions. I appreciate it very much. Thank you very much. Take care, stay healthy, stay safe, and see you on our next webinar. Thank you very much.